Okay, chapter 9, the last chapter in the book, talks about statistics, scatterplots, and data analysis. So the first lesson here, we're going to talk about scatterplots. So you might remember these from the standardized test that we just took. So you always see scatterplots, which is basically just looks like a bunch of dots, okay? But they do represent data columns. So we talk about bivariate data. The bi part means two, variate, of course, variables. So we're talking about two variables. We're talking about dependent and independent variables. So the same thing that we've talked about before, all right, your x's and your y's, and you're just putting the dots on them. So whereas we've graphed things before, they've always made a nice, pretty straight line. Well, things in the world don't always end up in nice, pretty little packages like that. So we're talking about scatterplots, which I think actually are more realistic of how things actually look. So if you construct a scatterplot, what you would do is you would have labels on both telling what they are. Talk about seasons and viewers. So season 1, 31.7. So season 1, dot on 31.7. 2, 26.3. 3, 25. 4, 20. So you put all of your data plots in. Now, even though this doesn't make a straight line, you can gather the trend. You can gather a trend of what's happening for the television ratings of whatever show this is throughout the seasons. So if you look at that, they are trending down, which means probably this show is not long for the air. It'll probably be getting canceled before long. So if you were to try this, which I'm not expecting you to do this right now, we can kind of do this one together. The first thing that you would have to do is you would have to label the x and y axis. So construct a scatterplot of the weight of an alligator at various times after hatching. Various times after hatching. So which one is dependent, which one's independent? So independent would be the one that doesn't depend on anything else. So that would be your time in weeks. That would be your time in weeks. So that would be my label here. So that means your dependent variable is your weight in pounds. Okay, weight in pounds. So then you just plot your data on there. So 0, 6, 0, 6. At 9 weeks, which is just before this, we're at 8.6. So again, you're kind of guesstimating here. You've got 8 and 10. So 8.6, not quite to the 9 mark, but I mean, really, it's about as close as you're going to get. At 18 weeks, they're at 10 pounds. At 27 weeks, 13.6. At 34 weeks, which is almost to the 35, 34 weeks, they're at 15 pounds. And 43 weeks, 17.2. And 49 weeks, which is just before 50, they're at 19.8, which is almost right on 20. So you can see this is a pretty linear. Now, could you take a ruler and make an exact straight line between that? No, but you can see how it is trending upwards, which you would expect because as it gets older, it's going to weigh more. Okay, no big deal, right? Let's move on. Maybe. There we go. So we got types of association. So this is what you just saw with the alligator and the hatchlings. So no, they are not exactly in a line, but they do give you the trending data points that you can tell that as time goes on, the value increases, right? So as time goes on, or as x increases, whatever your independent variable is, your y increases. That would have a positive association. Think of it like whenever we graphed lines, what was the slope of a line that slanted up like that? It was positive. Here we have negative associations, right? Negative associations. So as x increases, your y value decreases. Think of this something like, I don't know, time in hours spent shopping. And you can think of this being money. So the more hours that you spend, the less money you're going to have, right? Until finally you're broke. So that would be a negative association, because just as before, if a line slants down and to the right, that would be a negative slope. Now, this one, this is just saying there doesn't seem to be a trend in this at all. The dots are just all over the place. You can't really guarantee or can't really derive any kind of pattern from that whatsoever. Things are just random. Things are just all over the place. That means that there is no association, and that's what you would put. So positive, negative, no association. All right. So also with this, we've got things that are linear, which basically I could draw a line in there, and it kind of goes with the pattern. So could I draw a straight line through that? No. That obviously is going to have a curve to it, something that looks like that. All right. So of course we have linear and nonlinear. So things that are linear are going to follow the pattern of a straight line. Nonlinear, they're not a straight line. No tricks, just simple common sense on that part. Okay. As you analyze the graphs, you can not only tell me, is this linear, is it nonlinear, but you can also get other things from it. You can have outliers, which basically means it's kind of like the person who is not with a group, all right? Everything else is going to basically follow this nonlinear curve, but except for this guy. He's the loner. He's the one by himself. That's an outlier. It's like the outcast of the group. Now, I would not consider like this one right here an outlier. It has to be way off in order to be an outlier. But you could also do, come on, what? Get off of here. Oh, we just cleared it all. There we go. You could also locate clusters or things. You see how they're more spread out up here, but down here it's dense. So that would be called a cluster of data. So whenever you are analyzing these in your homework, you're going to tell me, is it linear, nonlinear? And if it's linear, you're going to tell me positive or negative association. You're going to identify if it has any outliers, and you will identify if it has any clusters. Okay? So with that, let's move on. Example 2. Interpret the scatter plot of the data for the amount of memory in an MP3 player and the cost based on the shape of the distribution. So, would this be linear, nonlinear? Does it appear to lie in a line, or does it look like it's going to curve? I would say you could probably set pretty well a straight line that goes right through there. Okay, so I would say it is linear. It appears to lie close to a line, so the association is linear. Is it trending upward? Is it trending down? Or is there no association whatsoever? It's as time goes on or as memory increases, the cost increases, which you would expect. Memory increases, the cost would increase. Think about like an iPhone. If you have like an 8 gig, 16 gig, whatever it happens to be, those all aren't the same price. So as the memory increases, the cost would increase. So it will have a positive association. Now, does it appear to have any clusters or outliers? Clusters or outliers. You can see that up here it's a little bit more spread out, but there does appear to be a cluster of data right there, where most of my points are down there. All right? So as far as outliers, really, remember it has to be way far out there. So if I put that line right about there, I wouldn't even consider that an outlier. It would have to be something like down here, something way off the trend. So no outliers for that one. Okay, so looking down here, let's do this part. Interpret the scatter plot of the data for the time elapsed and the temperature of water based on the shape of the distribution. So as time increases, the temperature goes down. So that would be a negative association. It does appear that I could put a line. Let me get my pen back here. That I would be able to put a line pretty well right through there. So that would be a linear association. And there's no clusters, really. They're kind of evenly spread out. No clusters, and there are no outliers. Looking at C, if they are all over the place, then that would be no association. No association. And really, if there's no association, it's all just kind of evenly just here, there, and everywhere. There's going to be no outliers, no clusters. Okay. Moving on. Table shows public school enrollment from 1999 to 2010. Construct and interpret a scatter plot of the data. If an association exists, make a conjecture about the number of students that will be enrolled in public schools in the year 2015. Okay, so looking at this, it says consider the different associations and patterns. As the years increase, the number of students increase. So that would be a positive association. As the years increase, the amount of students increase. Okay. It appears to lie close to a line. I could put a straight line somewhat through that, so that would be linear. There are no clusters or outliers. So there we go. So to make a conjecture about the number of students that will be enrolled in the year 2015, follow the pattern until the x value is 16. Now, why 16? Because these are years since 1999. So if I were to go to 15 years after 1999 is only 2014. All right, so I'd have to follow all the way out here. So where do you think it would be if I took a line? Again, these are going to be subject to a little bit of, what somebody may say, they may be a little bit off. There may not be one precise. It's going to be an about. So out to here, year 16, that's what we got. Where would that leave you? I would say it's going to be somewhere around 51 million. You could say 51.5, whatever it happens to be, but it's going to be somewhere around 51 million. Okay? So with that, there's one more here. You can look at it, pause it, try it. We can talk about it quickly. And then you are on your own. I think these should be a pretty straightforward lesson. Okay, should be able to see from this one that this is going to be a negative association. As time goes on, the values decrease. All right, so there would be a negative association. There's no clusters, there's no outliers, right? There's nothing way off the line. I could pretty well put a line through there. Now, it does dip a little in the middle, but I would not say that's a curve. I can put right there because it gets right back on track. May have just had a rough year here. Okay, so it wants to know the winning time in the 2016 Olympics. 2016 Olympics. So if that's 2008 and they were going up, right? So that's 2008, that would be 2004, 2000. So this would be 2012. So what would it be if it were right here? So let's get our line back out there. Actually, I could probably take this line. 2016 Olympics. 2016 Olympics. Okay, so the year 2016, about right here. So what would it say that is? I don't know, maybe 47, 46 and a half, somewhere in there. All right, again, it's going to be a little bit debatable. If you give me something, oh, it's going to be 40 seconds. Well, that's not what it shows. You got a little bit of free range there, but not craziness. All right, so with that, you should be good. Let me know if you have any questions. Good luck.